Hello, everyone, and welcome to today's webinar, Optimizing Your Lighting System for Maximum Efficiency and Yields, sponsored by PL Light Systems. I'm Robin Sitberg of Meister Media Worldwide, publisher of Greenhouse Grower Magazine. In this webinar today, we'll explore some of the strategies growers can employ to ensure the optimal performance and ROI of their lighting system. This presentation will cover some of those strategies, including good maintenance practices and lighting retrofit options, and also how they can help growers maximize their efficiency and yield. If at any time during the presentation you'd like to ask a question, just type it in the question pane at the lower left panel of your screen and click Submit. You can do this at any time during the webinar, and we'll answer questions at the end. Our speaker today is Eric Moody, Sales Manager for the Americas at PL Light Systems. In this position, Eric's been working with growers of all types of crops for years, helping them to develop custom lighting strategies that increase yield and optimize efficiencies. He has a lot of information to share, so now I'm pleased to turn the program over to Eric Moody.
Well, hello. Thank you very much. Good afternoon, everyone. As you heard, I'm Eric Moody. I do head up the sales for PL Light Systems for all of North America. For those of you who don't know, PL Light has been manufacturing professional quality lighting systems for the horticultural industry for over 40 years. We first opened our doors in our Canadian office and manufacturing facility in Beamsville, Ontario in 1981, and we are still based there, yet we have regional sales managers across Canada and the USA, so we're able to offer all of our customers local sales support, customer service, and technical support. We also have our sister company, horticultural, in the Netherlands. So with our sister company there and with us here, we're able to leverage that Dutch expertise from the horticultural sector, however, keeping our knowledge of our local markets here in North America as well. So we leverage both markets that way. So with that said, let's get started in today's presentation where we'll be discussing how we can optimize lighting systems for optimal efficiency and yields. The commercial horticultural industry has seen significant innovation over the past few years. The growing facilities of today look remarkably different than those considered to be cutting edge of design just a decade ago. The most significant innovations have been in CEA technologies. Driven by increasing energy and labor costs, growers have realized the advantages of investing in equipment and automated systems that will reduce their operating costs, including labor, maintenance, energy-related costs, and this all increases their bottom line. As such, energy-efficient supplemental lighting systems are a logical investment for most greenhouse operators. In today's presentation, we'll cover some of the advantages that growers can employ to ensure the optimal performance and get the ROI of their lighting system, as well as maximizing efficiency and crop yields. The first most basic thing you can do to ensure you're optimizing your lighting is to work with a reputable lighting company to develop a light plan customized for your specific facility and your application, and then install your lights exactly according to this plan. For those of you not familiar with a light plan, it's a calculation of the best possible coordination of luminaires in terms of their distance and orientation from one another, as well as the crop. The trick lies in determining the ideal combination of these factors to ensure that you will achieve optimum light output and distribution with as few luminaires as possible. The resultant light plan will provide a cumulative overview of the light output and distribution of the luminaires installed based on the prescribed mounting positions and orientation. Reputable lighting manufacturers will guarantee the light levels presented in their light plans, provided the luminaires are installed in accordance with the recommended plan, of course. If you're comparing light plans from multiple lighting suppliers, be sure that the data presented to you is a true indication of the actual performance you can expect. A new lighting system is a big investment and can significantly impact your yield. So ask questions. Is the proposed light output of the luminaire based on the lamp or LED's maintenance factor, that end of life? Some companies will use a light output for a lamp that is maximized to what the max of that light output, while some companies will offer a light plan based on that end of life, looking further down the road for you. So you're always looking at the minimal you will get from your light plan. And which of these is the best indication of actual performance? Does the light plan specify light levels in micromoles versus lumens or lux. There's that old expression out there, lumens are for humans, micromoles are for plants. So if you're dealing with a lighting company that's using lumens or lux to talk about their light levels, it's likely that they're not an experienced horticultural lighting company. Another thing to consider in a light plan is not only the guarantee of the light level, but the uniformity you will get from your light plan as well. And this should be something that a reputable company will guarantee with their light plan as well, because uniformity is very key to lighting your crop, to keep it growing uniform, to keep it using its fertilizers, fertigation, water, everything. All of that you want to be uniform, and lighting can disrupt all of that if it's not uniform as well. Many of you are probably familiar with the rule of thumb when it comes to light intensity and plant growth. We know that for every 1% increase in par light, you will see an equivalent increase in plant growth and yield. The same principle applies in reverse, of course, whereby each 1% of loss of par light will result in 1% loss in plant growth and yield. So maintaining the highest possible output from your grow lights is critical to maintaining optimal crop yields. One of the most obvious but often forgotten things a grower can do to ensure they're getting the best performance and efficiency of his or her lights is to properly maintain them. Just like any other equipment, luminaires need to be regularly maintained in order to ensure optimal performance. Two very simple but critical maintenance measures that every grower should be incorporated into their regular maintenance routine is they are using HID luminaires, or relamping and reflector cleaning. It's a fact that the light output of all luminaires depreciates over time. This is true for both HID and LED products, but HID lamps do, of course, deteriorate faster than LEDs. That being said, however, an HID luminaire can run very efficiently for years and years if properly maintained and the lamps are regularly replaced. For high-pressure sodium lamps, replacement is recommended after 10,000 burning hours to ensure optimal light output. Metal halide lamps depreciate faster than HPS lamps and are typically recommended to be replaced after 8,000 hours of normal operation. So if you consider the light intensity rule in the previous slide, where every 1% loss of par light can mean 1% loss in plant growth, you can deduce that if the useful par output of a lamp depreciates by roughly 1% per 1,000 burning hours, then after 10,000 burning hours, then that lamp will only have an output of 90% of the original output, which translates to roughly 10% loss of crop yield. So this is why regular replacement of lamps is critical to maintaining the optimal par light output of your HID luminaires. I'd be curious to know if many of you listening that are using HID lighting have a relamping strategy in place for your grow facility. And if so, what is it? Do you wait until all your lamps burn out, or you start seeing some burn out, or are you proactively planning so that all houses, bays, zones, rooms are all changed at the same time to ensure consistent light levels? Since the size and scope of crop facilities can be very large, group relamping can be very expensive and labor-intensive exercise if you don't have a well-thought-out strategy in place. So if we think about that, let's use an example to demonstrate. Say you have a facility with 1,000 luminaires, and the cost to replace a single double-ended lamp is $75. If you were to replace all of your lamps at the same time, that's an investment of $75,000. So that's a big chunk of money for a lot of growers out there. So when the life expectancy of a 1,000-watt DE lamp is 10,000 burning hours, the average use of supplemental lighting per growing season for tomato or cucumber greenhouse will range from 2,200 to 2,500 hours per year. Whereas a grower like a cannabis grower would typically run their lights roughly 4,000 to 4,400 hours per year. Geographic location would, of course, also affect the number of hours a greenhouse grower would need to use supplemental lighting based on the amount of natural light available. In an indoor grow with no natural light, but only sole source artificial lighting, you would obviously need to replace your lamps much more frequently. Typically, a lamp can last 2 to 4 years, depending on how much you're running it. This means every 2 to 4 years, that same grower with 1,000 fixtures or luminaires would need to spend $75,000 to maintain optimal light levels to produce optimal yield. If you had a relamping strategy in place, however, you could spread this out. You could potentially change a third of your lights at around 8,000 to 9,000 burning hours, so about 1,000 or so less than really what's required. Do another third of your grow right at that 10,000 hour mark, and then that final third of it at 11,000 to 12,000 burning hours, so 1,000, 2,000 hours beyond the rated life. Then a vegetable grower could spend the financial impact of roughly 25,000 in year 3 or 3.5, 25,000 in year 4, and 25,000 in year 4.5, thereby spreading that financial impact of that $75,000 out across a much longer period instead of having to spend that $75,000 all at once. When doing this as well, it's also a really good idea to have a map of your facility and a log capturing the burning hours for each area. This will allow you to plan for the staged replacement of lamps and can also provide good insight into how your crop is impacted by reduced light levels. Before we move on, I want to stress how important it is to ensure that double-ended lamps you're using are installed properly. Most HID luminaires on the market that use double-ended lamps use the same lamp holder brackets. Super important that the lamp is installed correctly and in the correct orientation, and that the lamp holders are fully closed when you're installing the lamp. If they're not, you'll end up with a loose connection that could lead to arcing. Again, you can check out video instructions on how to do this or download the PDF instructions from our website at pllight.com. Make sure your maintenance crew are trained on how to properly replace lamps. When you're replacing your lamps, you should always ensure the new lamps are compatible with your luminaires to ensure you're not risking the safety of or damage to your luminaires. Excuse me. For example, older versions of our NXT products can only accommodate HPS lamps, whereas the most current version can accommodate both HPS and metal halide DE lamps. Should you install a metal halide lamp in one of our older products, then you're quite likely going to cause a ballast to fail. You should check the product labels on your luminaires for the types they can accommodate. Ideally, you can purchase your lamps through your luminaire manufacturer to ensure they're compatible, but you should at least check with them before purchasing new lamps from other suppliers, since not all lamps are created equal. You also want to make sure you don't have more than 2 on or off cycles for your HID lamps within a 24-hour period, since this will shorten the life of both the driver and the lamp. This is especially true for the electronic ballasts, since repeated restrikes increases the stress on the high-powered electronic components. You should also always allow for at least 15 minutes before restarting an HID lamp once you've turned it off, to allow all of the gases in the lamp and the electronic components of the ballast and driver to return to room temperature. This will also help maintain the useful life of the lamp. We've seen this as growers have become more automated and rely on technology to control their lights. And I've seen growers that have had their lights turn on and off multiple times during a day from passing thunderstorms or dark clouds. And really, it's better for your lamps to just have that 2 cycles of on and off per day most. Another simple way you can make sure you're getting the most out of your lighting system is by regularly cleaning your reflectors. You may not realize it, but it's estimated that light output can be reduced by up to 10% due to dirt, dust buildup on a reflector. If not properly cleaned and maintained, this can mean a loss of quality in your crop, longer crop cycles, and reduced yield. Some lighting manufacturers will tell you that you need to replace your reflectors every year or 2. However, if they are good quality reflectors made from quality materials, this is not true. You can clean them. All of PL's NXT family of HID luminaires are designed so that the reflectors can easily be removed while the lamp is even still installed. To maintain the highest level of performance for your luminaires, we recommend that you check and clean your reflectors every year if possible. Ideally, this should be part of your cyclical maintenance routine and is as easy as removing the reflectors and washing them in a simple vinegar and water solution. You can actually check out the resources section of our website to watch a short video on how to do this. We have a video showing exactly the solution you can use and how to clean and dry your reflectors. Right now, as you're approaching summer and the days are getting longer, it's a great time for greenhouse growers to consider doing this, since they won't be needing supplemental lighting in a greenhouse for a few months. Indoor growers who use artificial lighting year-round should include an annual cleaning of their reflectors as part of their regular maintenance routine to ensure they continue to deliver optimum performance. Obviously, the aluminum material of the reflectors will start to degrade over time as part of normal wear and tear in a greenhouse environment. So at some point, you will need to replace them if you want to maintain your optimal PAR light. The trick is knowing where that tipping point is. So at PL Light, we actually offer a service to our customers where we can test lamps and your reflectors from the customer's installation in our lab. The customer will then get a full test report of the findings, along with recommendations on what can be done to extend the life of the current reflectors and or lamps. Alternatively, a recommendation that the relevant components need to be replaced in order to achieve optimal light quality. Basically, when you send in a reflector, we will test it and tell you how much reflectivity has been lost in that reflector. Then we will clean it, we'll test it again, and show you how much you've gained just by cleaning it. And if that gain isn't enough, if it's not back close to that, 98 or 100% of its original reflectivity, we might make a recommendation to replace it. Another good practice is to make sure the voltage you have specified for your luminaires match the voltage you have in your building. This applies to both LEDs and HID. We always recommend speaking with a licensed electrician before deciding what voltage to use to run your luminaires. The luminaire voltage will be noted on the product label. A luminaire with a product label stating 120 volt to 240 volt will accept any of the three voltages of 120, 208, or 240, and it will automatically sense the supplied voltage to ensure the same output to the LEDs, regardless of the input voltage. A luminaire with a product label stating 277 volt will only accept the voltage of 277 volt. When it comes to lighting, we typically recommend going with the highest voltage available at your facility, which will be the most efficient. By using a higher voltage for your application, you can lower driver and conductor losses and increase efficiencies. But you should always consult your electrician in advance to ensure you have an adequate power supply from your lighting and other equipment, including your HVAC. He will need to consider your facility's capacity, conductor sizes, circuit loads, voltage drop, and the full design. One request we get a lot, knowing that we can be more efficient with the higher voltages, is for a 480 volt driver and ballast. That is one thing. There are manufacturers out there that are producing a 480 volt driver, but what we have found with our tests is we have not found a reliable 480 volt driver that we would put our name behind and sell, because they tend to have very high failure rates and they don't last. So we do have very, very reliable 347, 400 volt. So the higher voltage we can get to, the better. And some horticultural lighting companies date back more than 40 years. There are some facilities where upgrading the lighting system is really the only way to achieve greater energy efficiencies and maximize light output. Most people assume that means upgrading to LED, but that's not necessarily the case. The most current HID lighting with electronic ballast and DE lamp technology is actually highly efficient and can be a very cost-effective way to upgrade from the older magnetic ballast lighting systems. One of our customers, Burnaby Lake Greenhouses, located in BC, Canada, did just that and achieved very impressive results. Burnaby Lake Greenhouses is a third-generation grower of ornamentals and potted plants. They replaced their old 600-watt PL2000 luminaires, which we began selling in the year 2000, with our new NXT2s and alpha reflectors. They initially set up a small trial area with 12 NXT2 luminaires. The trial was a success, with the new lights exceeding their expectations in terms of improved growth, uniformity, and performance versus the old 600-watt luminaires. So in 2017, they converted their entire greenhouse to the NXT2 and achieved a greater energy and lighting efficiencies, had superior plant growth with a short payback period of less than a year. They switched out 360 of their 600-watt luminaires with just 150 of our 1,000-watt NXT2s. This new retrofit meant they needed 58% fewer lights than the original installation, thanks to the improvement in the NXT2's design, resulting in higher light intensities and distribution. With the new NXT2 luminaires, they achieved a substantial increase in light levels compared to the old PL2000s. They also used 53% less power than before, since the NXT2s with the high-efficiency electronic ballast used only 150 kilowatts versus the old PL2000s that were using 216 kilowatts. This saved them approximately $144 a day in electrical costs, with a payback period of 348 days, which is obviously less than a year. Since the customer is highly committed to environmental sustainability, they wanted to trial some LEDs before installing the NXT2s, since LEDs are obviously known to be more energy efficient. However, after the initial trial, they discovered the spectrum emitted by the LEDs they trialed was too specific for growing roses. Since they grow many different varieties of roses, all having different lighting requirements, they found some grew well and some did not. Therefore, they couldn't justify installing LEDs, especially since they saw such great results from the NXT2 HPS luminaires. Also, they achieved better light penetration with the NXT2s and decreased heating costs in the winter due to the radiant heat emitted by the HPS luminaires compared to the LEDs. This is an important thing to consider. The LED lights can be very, very specific in their spectrum. And I see a lot, especially in the world of cannabis right now, I see a lot of LED manufacturers claiming that they have the correct spectrum to increase terpene levels and increase THC levels in their plants. However, what we find is that can be very strain specific, that some strains don't grow well under LEDs. Some strains perform better under the NXT2s. If you think of just about any type of plant, and I'll use cannabis as since I'm already there, it has grown anywhere from far northern climates all the way to the equator. When the sun comes through our atmosphere at different angles, certain colors of this color spectrum come through better than others. So the plants, all plants, roses, tomatoes, you name it, have all learned to grow under different varieties, under different spectrums. So trying to be too specific with the spectrum you're using can be good for some plants and not as good for others. Another option is to install a hybrid lighting system, or a mix of LED and HPS luminaires, which allows growers the benefits of both technologies. A hybrid solution provides the flexibility to take advantage of the radiant heat and the diffused light of the HPS reflector, but also the energy efficiencies of the LED. It also allows greenhouse growers to extend the supplemental lighting period longer into the spring by using only the LED lights when we have warmer outside temperatures and daylight hours increase. A hybrid system also reduces the initial CapEx and can allow a grower to further manage costs by maintaining their existing infrastructure. Really, a hybrid solution can provide the ideal balance. Let's take a look at a couple of application examples to illustrate the differences between the different systems. Here you can see some comparative light plans based on an all HPS versus an all LED lighting solution for the same application. The HPS solution, we achieved 445 micromoles with 99 of the 1,000 watt luminaires. These luminaires are hung on the trusses, 10-foot spaced, it's a 10-foot spaced truss, to achieve the same level. To achieve the same level for the LEDs, we need to use more luminaires than the HPS layout and cannot achieve the uniformity, nor fit them all if we try to hang them on the trusses. So in this case, we would have to install additional track to fit the number of LED luminaires required. Something to consider when doing this is now you're also adding more shading into your greenhouse by having more structure above your crop. The reflector technology and the HPS luminaires help to diffuse the light by reflecting and refracting photons around the grow area in different locations. If you ever look at most HPS luminaires, you'll see that dimpled effect in their reflector. This dimpling is what helps diffuse the light. If you hold your hand directly under one of these fixtures, you'll see your shadow looks blurry. That's that diffuse light that really helps penetrate a crop. This is different from an LED that directs photons very directionally downward. So while the plans have the targeted same light level on the canopy of the crop, you also need to take into consideration how those photons are being distributed into your crop, deep within and below your canopy. For the LED application, we used 168 luminaires of our 1100 micromole output fixture. We were producing 168 luminaires produced a total of 184,800 micromoles for this entire space when you multiply the 1100 times 168. If we do the same thing with the 99 HPS luminaires and use 2100 micromole output, we are producing 207,900 micromoles of par light. So the question is, which one will your crop perform better? The simple answer looks like it would be the HPS luminaires because of the higher amount of total micromoles being delivered. However, if your plant and the strain of your plant is utilizing the red and blue wavelengths, specifically in the LED luminaire that has the stronger red and blue light in it, this area of the par spectrum, so if the plant is using that more efficiently, then maybe the LED luminaires might work better for your crop, even though it looks like it's a lesser overall micromole number. Let's take a look at a hybrid plan. This is a hybrid LED and HPS lighting system. In this plan, we replaced every other HPS luminaire with 2 LED luminaires. The spacing of the luminaires also means that they can still be mounted on the 10-foot truss rather than having to install additional track, as was the case with the all LED solution. You can see that the hybrid solution, the incremental CapEx cost is $59,900 more than the HPS versus the $115,000 more for the all LED solution. Yet it still offers an energy savings of 26%. So a hybrid solution in many cases really does offer the best balance between performance and efficiency and could be a good way for someone who has an existing HID installation to improve their efficiencies while maintaining the benefits of HID technology by switching out every other HID luminaire with an LED. Remember that we are looking at the lighting costs alone in these calculations. To really figure out what solution works best for a particular project, we need to also factor in relevant infrastructure, heating and cooling costs, determine which way to set up your grow to truly offer the best ROI for each application. I'd like to point out that in this system, the way we have done this, we have an 1100 micromole output LED. So we replaced 1 HPS with 2 of these LEDs. There's a lot of chatter in the market today about LED companies claiming they have a 1-for-1 replacement of an LED for an HPS. This is something that I have a really hard time believing in. And the reason I say this is because if you were to hold a light meter directly under an HPS lamp and directly under a really high-powered, maybe a 600-watt LED, you would see directly under that LED a light level as high or maybe even higher than what you would see under the HPS. However, again, because of the lack of reflector technology behind the LED and the directional light, when you move that light meter to 45 degrees from underneath the LED, you're going to see a very rapid drop-off in light level. Whereas with an HPS, when you do that, for most HPS fixtures, it's going to stay either uniform, or some fixtures and reflector technologies, it increases at 45 degrees. Combine that with the fact that the diffuse light of an HPS is bouncing photons around more and penetrating the crop more, while a very directional light from an LED will cast very sharp shadows off of those top leaves of the canopy. I really have a hard time believing that there's a true monster out there that is a 1-for-1 replacement to a 1,000-watt double-ended HPS fixture. So I would say in conclusion, no matter what type of lighting system you're using, there are many ways you can ensure you're getting the most out of it in terms of efficiency and performance to achieve maximum crop yields. Each application is unique, So you should discuss your particular situation with a trusted lighting partner to see what strategies and improvements you can make in your operation. And by a trusting lighting partner, I mean somebody that's going to work with you to do a lot of the things we discussed. Not only are they going to sell you fixtures, they're not just going to sell you fixtures and luminaires for your crop, but they're going to design it in a way that they can show you your benefits and your pros and cons of using HPS, LED, or a hybrid solution. They can provide you light plans for all of these things. They're going to guarantee those light levels, guarantee the uniformities you're going to get. They will then partner with you in the long haul of, okay, I sold you your fixtures on this date, so we need to be planning a conversation 2, 3, 4 years from now of when we're going to start replacing your HID lamps. What are you doing to clean your fixtures? What is your maintenance schedule? So partner with somebody that's truly going to help you over the course of your grow. It's not always about, I'm going to find the cheapest fixture I can because I'm just going to put lights up and I'm never going to look at them again. The lighting you purchase for your grow is one of the biggest investments you're going to make in your grow. So it's just like if you think about buying a car. Are you going to buy a car that you know your family is going to be safe in while they're driving, that it's not going to break down on the side of the road and it's going to last for a long time? You want to have that same kind of thought when you're investing into your grow. Are you purchasing from a manufacturer who's going to be there to support you, who can be local to support you, and who's going to partner with you in the long haul? Whoever it is you're using, I suggest you ask these questions above and beyond just the cost of the lights to make sure you are partnering with somebody that will do this for you. If you have any questions and looking for a partner like that, obviously, we have our contacts of our sales managers from across the country up on the screen now. Feel free to reach out anytime to myself or anybody you see on the screen. We're happy to help you. That concludes my presentation today. I think we're going to open this up for questions now. If anybody has any questions, I'm going to start looking at them as well.
Okay, thank you, Eric. And yes, we are now open for questions. We've had several of them coming in during the webinar, so we'll start with those. But if you have a question, just type it into the questions pane at the lower left of your screen and hit send. So the first question that came in is wondering if you could comment on passive non-electric technologies that modify sunlight spectrum for greenhouses.
You know, I am definitely not the foremost expert on that. I have seen some of these things. There's a company out there now that does just this. They, you know, I haven't had any experience myself with that. There is a company out there, and I'm forgetting the name of this company off the top of my head, but they do just that. They have a coating that covers the outside of the greenhouse. It can adjust the spectrum of the natural rays coming into the greenhouse and can actually, I believe, adjust it to the point where it's maximizing like what an LED would do, where you'll get higher or increased levels of blue and red spectrum on it. But I'm not the expert on that and couldn't tell you.
Okay, fair enough. The next question is, does the driver life affect HPS output over time, and should drivers be changed at certain intervals? Well, your driver comes with a warranty. Most of them have I believe, a 3-year warranty on them these days. They, the job of the driver when running a 1,000-watt HPS fixture is basically control that lamp. That lamp itself will want to pull as much power as it can until it would explode itself. So the job of that driver is to feed just enough power to that lamp that it will it'll be at its max without exploding itself. So as your power comes in, your power is never perfectly set at exactly 277 volt or 347 volt. It's going to fluctuate up and down. So your driver is working that whole time to try to keep that as uniform as it can into that lamp so it's producing its exact output. Over time,
as a lamp starts to wear down, it starts trying to pull more from the driver. It's trying to pull more power because it's decreasing its output, and it's trying to pull more, basically acting like it's hungry again as it's getting towards the end of life. And that starts putting a strain on the driver, and eventually you'll see that lamp is out and the driver can't run it anymore. So on the flip side of that, as the driver gets old, does it fail doing that? The driver itself would more fail than it would decrease the output. So to that point, I wouldn't say there's a regular maintenance schedule for replacing your drivers. Once you start seeing some failures pick up in your facility, then it might be time to start looking at replacing. But typically they last long enough that you're either replacing the full inside of the fixture and keeping the housing, or just replacing your fixtures in general.
Okay. This next question also refers to aging lights, and it's how fast do HPS lights dim over time? What is the percentage of loss per year? And they comment that they usually run the lights actively about 16 hours per day throughout the year.
Right. Well, the golden rule of thumb, like we spoke about, is that 10,000 hour mark. As you hit 10,000 hours, everybody's lamps are a little bit different. I would say there's a lot of, especially now with the 1,000-watt double-ended technology, there are a lot of companies out there making. There are companies that, even some of the lamps that we sell in our fixtures, the company that we purchase them from, we purchase a higher end lamp, but they sell another lamp that's just a lesser version of the one we use. So, I see it a lot of times where people ask me, why is your lamp more expensive than this? I can buy the same manufacturer lamp, but when you look at the spec sheet and you realize it's different. So everybody's specs are a little bit different from each other, but basically there's kind of that curve of, if you want to call it dimming, but less output, that really starts to increase at that 10,000 hours. So, if most of them will stay within 10% of their output at 10,000 hours or better. But there are a lot of them out there. It's that old rule, right? You get what you pay for. There is some cheaper technologies out there that will have a sharper decline in their outputs at that 10,000 hour mark or before.
Okay. Thank you for that answer. The next question is, we've got an interesting concept. In a hybrid system for high wire crops, would it make sense to use HPS for top lighting and LED for interlighting?
We get this question a lot, and we went down this route for a little while as well. And interlighting's an interesting concept, and results from interlighting have been all over the board. We've seen results claim very, very high impact on their yield to very, very minimal. When you dig into some of these papers that you see written on interlighting, you'll find, like the ones that are really high, it's typically a grower that went from having no supplemental lighting at all to all of a sudden they put interlighting in. So obviously they're going to see a big return because they've just added light to their crop. I would say that interlighting is a struggle for a lot of lighting manufacturers, and we struggled with it as well. It's not a great environment for a high dollar piece of electronic equipment to be down deep into your crop. You start getting buildup of sulfur and hard water and all sorts of things on your fixtures. I've seen some fail in pretty catastrophic ways with some manufacturers that were doing this. And I will admit it was a very harsh environment in this particular grower. I saw them fail, probably a little more so than normal. So because when we've looked at a top lighting grow who then added interlighting and saw very, very minimal increases, we could not justify the ROI for it. I think most are sticking to just the top lighting alone, and especially we've seen a huge increase in doing the hybrid system and their top lighting of greenhouses right now.
Okay. All right, we'll move on to our next question here, which is, will it be beneficial to install PAR sensors along the canopy to keep track of lighting system degradation over time? And if so, how many sensors do you recommend, like one per however many feet?
That's a good question. Definitely, I'm a fan of having PAR sensors in a greenhouse. What I would say is, and we spoke about it a little bit in my presentation about striking your fixtures too often over a 24-hour period. So I've seen a lot of control systems that are hooked into these PAR sensors, and every time the light level got below a certain amount, they would kick the lights on. And then it would run for a little while, and sensors would tell them to turn back off, and next thing you know, you've got fixtures turning on and off a lot. So I say you have to be very careful with that. But there's two trains of thought there. There's no, I know what time of year I'm going to turn my lights on. I know when I'm going to run them. I think you can be much more efficient by using a PAR sensor to tell you, because you're going to have days of sunny, beautiful weather in the winter that maybe you don't need to run your lights as much as you think you do. That can definitely happen. As far as recommending placement and how often to put them, I don't believe you need a ton of them, but I'd say that's a better conversation to have with one of the sensor suppliers. It just depends on, obviously size of your grow and, your grow area, how many zones. I mean, I would think you would minimum one per zone, but that's really a question for the PAR sensor folks.
Okay. We'll move on to our next question, which is about ROI. And it says, if you factor in the maintenance costs and relamping costs, do the LED lights have a faster payback?
Oh, of course they do. LED lights, especially those that are listed on the DLC website right now, have to have, I believe, a 5-year warranty. So if you think about that, that means you're going to have a light in there for 5 years, and the only maintenance you're going to do to it is maybe wipe it down and clean it. Where 5 years with an HPS fixture, you're probably getting close to maybe having to replace the fixtures themselves, but obviously you've replaced lamps at that time, you've also done the same amount of cleaning that you would do with your LEDs. So yes, that ROI does come faster, but there's so many other things besides just that. We've seen customers that looked into doing, especially in a northern climate, doing LEDs, but they found out that their savings that they were getting from the electrical on the LEDs was more than offset by the cost of gas it was going to take to run their boilers to heat them in the winter, versus what they were getting out of their lights and the radiant heat of the HPS. So there's a lot of factors to consider, and everybody's a little different. And some of your, fully indoor cannabis growers in these southern climates of Arizona and Las Vegas, and they pay a lot to cool a grow with all of these HPS fixtures in it. So a lot of times with them, just the LED alone and the savings and coolings can be huge.
Okay, and there's another question that's similar to that, and I'll just ask it in case there's anything else to add. What does HPS bring to the hybrid system? Is it only the reduction of the cost of the installation, or is there also an advantage in the production? I know you talked a little bit about the heat advantage or disadvantage, as it might be. Is that the only thing?
Yeah,
or
no, there's a lot to that actually. As we talked about, LEDs can be very, very specific in their spectrum output. You can run just a red, medium, blue LED. You can run what they call a full spectrum LED, or we do in a lot of our greenhouses, we will do a red, blue, white LED. So it has a little bit of that full spectrum, but a lot of that red and blue. So if you mix that with the HPS, that offers kind of a wider spectrum, also more towards the flowering side. So that's why it looks a little more yellow, because there's a lot of red in there as well. So when you do the combination of those, I think it covers that broad spectrum of plants a little better. HPS has been a proven technology for years. So now you kind of mix those two, you get the best of both worlds. But yes, then you also you're using the HPS for heat in the winter. You can not run the HPS and just run the LEDs on warmer days where you just want to extend the day period a little longer. So I just think there's a lot more options in a hybrid solution, and opens the door to more things for you, makes you definitely more efficient.
Okay. All right. Great. One of our listeners wants to know what type of lighting system is best for cucumber cultivation.
Well,
is that too broad of a?
I was just going to answer that with, well, a PL lighting system, of course, is best for cucumber cultivation. I think is the quick and easy answer to that. But, you know, we've got a ton of customers that are growing cucumber under HPS and have for years and do very well on it. I don't think I know of, off the top of my head, any cucumber growers that are, you know, growing cukes under LED. I'm sure they're out there. I don't have any customers, but we definitely have seen a lot doing HPS for years. But again, there's no reason why LED wouldn't work for cucumbers, or a hybrid system for that matter would be great for cucumber as well.
Okay. Okay, good. You spoke about cleaning the reflectors, but somebody would like to know, should they also be cleaning the lights themselves?
Well, you don't want to touch the actual lamp, if that's what they mean. You want it as minimal as possible. If there is a buildup on it, anything that can get on that lamp can make it so hot it can fracture that glass. So it doesn't hurt to wipe that down with a soft cloth. But if the question is about the luminaire itself, I'd say yes, for sure. And, you know, we've seen some come back through our service side that have been, I think they're just in greenhouses in an area when they open up their vents, they suck in a bunch of dust and dirt from outside, and it's amazing how much stuff can build up on a fixture. So when you get that buildup on the fixture, it takes away from that. You know, one of the great things about the PL Light NXT fixtures is the way it dissipates heat. I believe the body of our fixture dissipates heat away from that driver better than most with the cast aluminum that we use. So when that gets a lot of dust, dirt, build up on it, it takes away from some of those properties. It doesn't allow it to dissipate the heat as well. So it's always good to clean not just your reflector, but the luminaire itself. Same thing goes with LEDs. Our LEDs are passively cooled LEDs. We don't believe in trying to have a fan to cool our LEDs. We don't believe it's a good idea to try to run some sort of glycol or water system to every fixture to cool it. So we've designed an LED for passive cooling. So same thing, it has kind of fins across the top of it that are there to help dissipate heat away from that driver. And if that gets clogged up with dirt and grime, then it takes away from those properties. So you always want to be able to wipe those down as part of your normal maintenance.
Okay. Excellent. Here's a question here. Does it really matter what bulbs I use in my fixtures, provided they're the right type? Because I can really get some good deals online.
Yeah, I spoke about that just a little bit ago, and it's that same conversation as you get what you pay for. Like I said, most manufacturers have kind of their premium 1,000 watt, and then they also have one that's not. And a lesser lamp can make your driver work harder, which can decrease the obviously the life of your ballast. So you always want to check with the manufacturer of your lamp, of your luminaire, to see what lamp you purchased with it. And this lamp I'm looking at, is it going to be fine in our fixture? We recently had a customer who was seeing some really big failures, and it scared us because it was a failure rate higher than we would normally see. And they shipped their fixtures back to us so we could do a couple tests on them. And this was recent, where we couldn't go visit them thanks to our COVID-19 situation. So they shipped them to us, and they came with some lamps that I'd never even heard of or seen before. And the lamps were definitely causing some issues with the driver, making the driver work a little extra harder. So it's always something to think about for sure. Okay.
The next question sort of relates to that. I see LEDs that say they are a 1-for-1 replacement to a 1,000-watt HPS. How do I confirm this is true before purchasing?
So I touched on that earlier in my presentation, and it's something, like I said, I don't believe it's there. There's a lot of claims being made to it. But how do you confirm that before purchasing is obviously through having a true light plan done that is guaranteed by that light manufacturer, that's going to give you the uniformity. And that's really key there. Is it's one thing to say, yes, you're going to have 200 micromoles on your crop, just like you had with your HPS. Well, that could be fine, but is that because directly under your LED you have 400 micromoles, but out there between two rows of LEDs you're down to 100 micromoles or less? And that's why the average might be 200, but what does that uniformity look like? And then the real thing would be, and this you're not going to be able to see on paper or in a light plan, is what does it look like deep within your canopy? And that's where I go back to, I don't believe there's a true one-for-one replacement, because I don't believe LED placed out in the spacing that we do with our 1,000 watt HPS fixtures can truly penetrate and get deep into a canopy as HPS. Now, when you have to, one of the reasons why we don't try as a company, PL Light, to put out an LED that we would claim that our LED has a lesser output and it's only 335 watt, but meanwhile there's some that are 600, 650 watt LEDs that are claiming that one-for-one replacement. We would rather have more LEDs in a greenhouse to get better uniformity than trying to do one real high-powered one spaced really far away from the next real high-powered one, because we know you're not going to get the overlap between those two fixtures. So with us, we looked at it and developing our LEDs to how do we get good uniformity, because with that uniformity does come better crop penetration as well, because we get some overlap between fixtures. So I would say before purchasing, make sure you're getting that guarantee on what that uniformity is. You want to be able to see where the lowest light level is and what the highest light level is across your grow.
Okay. All right, our next question is about any input on lighting spectrums to increase rooting for propagation houses.
I'm sorry, say that one more time.
I'm sorry, maybe I said it wrong. Any input on lighting spectrums to increase rooting for propagation houses?
Yeah. I would say that a little bit of, and we've seen some tests that say a little bit of far red added to it will help increase rooting. But also I look at rooting as like the foundation of a house, right? Like to get a good plant, you have to have good root structure first. One of the things that comes with good root structure is heat. There's a direct correlation between the amount of heat on your plant and in the rooting bed, that direct correlation of how it grows and develops versus how much you have on it. Obviously, you get to a point where it's too much and you do more damage, but HPS is obviously a good way to always have good heat. LED, a full spectrum LED, I think is definitely recommended. Maybe a full spectrum LED with a little far red would be good, but a full spectrum LED with the ability to have some good heat is going to be probably the best thing for your rooting.
Okay, great. Well, we've got a couple more questions. We're getting towards the end, but this next one is looking at energy consumption. What's your opinion about intermittent lighting? Does it affect crop performance?
Intermittent lighting. Is that like flashing lights on and off, I assume?
I'm thinking, or I'm not entirely sure.
Yeah, I would say, obviously, like we said, we don't want to strike our lights more than twice every 24 hours. So I would stay away from it. I've seen a lot of things over the years with light movers and stuff like that, and I'm not a fan of any of those. I'm sure they have their pros and cons about them, but I truly believe it's about getting your plants to absorb a certain amount of moles of light over the course of your lighting period, and doing it intermittently or however you do it. You know, if you're a producer of tomatoes or fruits or whatever, you're going to want whatever that target might be for you, upper 20s, 30, maybe even 35 for the cannabis growers of moles over your photo period, your lighting period. So some crops, obviously, you can light longer than other crops, but it's really about the total amount of moles delivered to your crop over your photo period. And, there's a rule with that, and the cannabis guys know it well. They like to really push it extra, but you can get to a point that you're putting so much light on your crop that the crop isn't able to keep up with it anymore. So you have to then add CO2. So there's different limitations that come into play as you start maximizing all of these things in your grow. So I don't know if that answered the question about intermittent lighting, but I would say when it comes to lighting, it's about how much overall moles of light your crop is absorbing in its photo period.
Okay. All right. Thank you. We've got time for just one more question, and then I think we're going to have to wrap up. And that final question is, what are UV or purple lights used for?
Good question. And there's a lot of studies being done on UV lighting right now, and PL light doesn't really touch it much as of yet. What is it used for? It's not an area of my expertise for sure, so I apologize. I'm not going to probably offer a really great answer on that. There's a lot of studies that are just in their infancy and a lot of conflicting reports as to what UV can help with growing. Obviously, first and foremost, it has been proven that UV does help, and it does help in the growth, but it's the amount that's really in question. There's a very tiny amount of UV that comes down with an HPS fixture, and you'll see reports that say this is why I grow with HPS and not LED, because the LEDs out there didn't have UV at this time, and I needed UV on my plants, and they did so much better under the HPS. Well, was it truly that little bit of UV that helped the plants do better, or was it just the radiant heat and all the other factors that come into play? So that's a tough one to answer, and I'm not sure there is a right answer for it yet anyway.
Okay. All right. Well, great. Thank you so much. We're getting close to out of time, so this is going to wrap up the webinar. As a reminder, an on-demand version of this webinar can be archived, or will be archived within the next few hours, and it will be available at the same link you used to register and get online today. So I want to especially thank Eric Moody for providing all the information, and also to PL Light Systems for making the webinar possible. And of course, to the audience, thank you for joining us today. Have a good day.
Thank you. Bye.